Who's ready to balance some equations? I think you guys are. Video 7.3. Notice the other two probably took you all of 15 minutes to go through those. This one, we're going to kind of work through this. I'm going to show a lot of practice examples. So if you feel confident, pause the video, then go on and try them on your own, then finish watching it. Guys, it's a process. I know a lot of you, and I say this on the videos, a lot of you are skipping the process. I show you it a certain way for a reason. You guys are not experts. Don't try to skip steps yet. The things I'm showing you are to try to make your life easier. Okay, so follow them. Go through this video, practice both of these. This is just basic balancing. You can use a separate sheet of paper to do that because there's not a lot of room. I want to see your work, okay? So when I come around and check it, I'm going to ask for your work on at least the first 4 or 5 reactions that I want to see before you start trying to just do it without showing your work. If you don't show me the work, all right, it's not going to, I'm not going to, you're going to have to go back and redo it. Then, word equations. More practice with naming to write those. So practice those. That's what your quiz will be on. Should take you probably, you can get through the first 3 videos in the first day, but then practice for a day or 2 before you take the quiz. Have me check your work before you take the quiz. So many of you are not doing that. You're just trying to rush through it, and then I'm seeing it on your quizzes. Okay? So anyway, let's jump right in. Balancing. It's not too difficult. Some reactions are more difficult to balance than others. So there are some tricks that I will kind of show you. The thing we got to remember when we write equations is that it must satisfy the law of conservation of matter, where matter cannot be created or destroyed. That's a review again from Unit 1. We've already talked about that. So we must have the same type and number of each atom on each side of the equation. Okay, so that's really what we got to do is have the same number of atoms, same type of atoms on each side of the equation. So you always want to start, if you start with a word equation or an unbalanced equation, you got to start with a balanced equation. So that's that's what we're trying to do is to balance it. So if you start with a word equation, you got to write it out. Okay, convert to a formula equation. This just means that you go from a name to a formula here. Okay, write chemical formulas. And what do I put here? And I'm even going to highlight it, and I would encourage you guys to do the same. Diatomics, do not forget those. You will see them. If you that's probably the mistake you'll make if you mess something up. Now, what I typically do, guys, and this is after I've balanced hundreds and hundreds of reactions, this is kind of the fastest process that I've found. Doesn't mean you have to go in this order, but don't be surprised if you run into some snags and stuff and it takes you a little bit longer because you try to do your own thing. What I always do is balance all of my metals first. Then I will look for my polyatomic ions, if they're present. Not every reaction is going to have polyatomic ions. And the other thing you got to keep in mind is that it's on each side. Okay, so if you have a polyatomic on each side of the reaction, you can balance it as one unit. What I mean by that is a package deal. Keep them together. If you see them on both sides, 1, put your parentheses around them if you see them and they don't have parentheses. 2, balance them as a whole entity. Okay, don't try to just split it up into each individual element, because if you notice, a lot of your polyatomic ions have oxygen in them. You're going to find that oxygen will oftentimes be in the form of water on one side of your reaction. It'll also be by itself. Okay, so if you can try to make it a little bit easier than on yourself, do so. After you've balanced your metals and your polyatomic ions, if those are present, balance all your other non-metals, saving hydrogen and oxygen for last. Trust me, save these 2 for last. If you don't follow any other rule, save hydrogen and oxygen until the very end, because they are oftentimes, again, in the form of water. So it's easier to balance everything else first, and they will kind of balance themselves out if you've balanced everything else. Last step, people forget to do this. Check if coefficients are not lowest possible, reduce them down. I saw some of you guys do this on in the last unit with nomenclature, where in ionic compounds you had something maybe like this, where you had like, I don't know, Mn2O4. You've got to reduce that down to MnO2. Okay, chemists are all about making money. right? That's what drives everything. So if you have more moles of something and you're using it, well, it's just going to go to waste. So we want to make sure we reduce them down. And remember, never, ever, 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 ever change subscripts. You're only changing coefficients when you're balancing an equation. The only time you're dealing with subscripts is if you're going from a word formula to a chemical formula. Once you have it set, do not change them when you balance. Only use coefficients. So I'm going to show you guys the process, and it's going to take this. It could take you 2 or 3 to kind of get it. It could take you 15 problems to get this. I want to see your work until I've seen that you can master this. You've got to show me this first in person before I let you kind of go with, running without any reins or anything like that. So let's start with number 1. What I will do is I will draw a line where my arrow is. That's separating my reactants from my products. Reactants are on the left, because think about it this way. Reactants react together to produce products. Okay, so my products are over here. Now, we got to make sure that we have the same element, the same type, and the same number on each side of the reaction. So I'm going to put a P here because I've got phosphorus on the left and I've got oxygen on the left. I've got phosphorus on the left over here, and I've got oxygen as well. Now, I like to personally keep them in the same order, no matter, which ones come first or second on either side. I just like to make sure, because then I'm looking right here. Oh, I've got phosphorus lined up. It's easy to see. And I've got oxygens lined up. Easy to see. So the next step is now, okay, how many atoms of each do I have? So on the left, I don't see a subscript. Well, if there's no subscript, what number do we assume that to be? That's a 1. How many phosphorus atoms do I have on the right? I have 4. I have 2 oxygens on the left, and I have 10 oxygens on the right. Now I'm going to use a different color to kind of show you guys how we're going to do this. So all I've done is bookkeeping up until this point. Okay, I've figured out how many I have, so now I'm going to start going through to balance with coefficients, not subscripts. Okay, now it's going to sound confusing, but the more practice you see, that you'll start to pick it up. If you're struggling with this, again, ask me in person and we can work together. So I'm going to start with my metals. Do I have any metals at all in this reaction? No. Then I'm going to go on and look for polyatomic ions. Do I have any polyatomics? No, I don't. Okay, look at your table E for polyatomics. Nothing's there. So now I'm on to my other non-metals. Well, it says my last one, save oxygen for the last. So I'm going to start with phosphorus. Okay. Well, I've got 1 phosphorus on the left, and I've got 4 phosphoruses on the right. So I need to put some coefficient here to get me to 4. So the way you got to think about this is 1 times what equals 4? Well, that's pretty easy here, 4. So that means I need to put a 4 up here. Okay, because now when I have coefficients, they distribute out to everything in the compound. Now in this case, it's just an element. So 4 moles of phosphorus means I have 4 over there, which means I also have 4 over there. Now, phosphorus are balanced. So a pencil is your best bet, guys, your best tool to use when you're balancing equations, because it's kind of a balancing act. No pun intended there. All right, it's a puzzle. You've got to figure out how to get everything balanced out. So you're going to be doing some erasing. So make sure that you take your time, you give yourself space early on, and that you use a pencil so you can go back and erase. So phosphorus has been taken care of. I've got 2 oxygens on the left. I've got 10 over here. Well, think to myself, 2 times what equals 10? Well, to get to 10 total, 2 times 5 gets me there. So I'm going to put a 5 up here because now, notice, oxygen had a 2 there. So my coefficient is going to distribute in. 5 times 2 is a total of 10, which is how many I had on the right. So you're trying to get your coefficients. When you put a coefficient up there, it's multiplying by whatever subscripts to get you the total number of atoms. Okay, so we have 5 moles of oxygen gas, which means 5 moles, and oxygen exists in a diatomic state. So that means we really have 10 atoms of oxygen in 5 moles. Well, anyway. So, first one, again, if that doesn't make a lot of sense, keep rolling. Let's move on to number 2. Okay, again, bookkeep. So I'm going to draw my line to separate my reactants from my products. I've got sulfur up here on the left. I've got oxygen on the left. I've got sulfur on the right, and I've got oxygen on the right. I have a total of 1 sulfur on the left. I've got 1 sulfur on the right. Hey, look at that. Those are already balanced. I don't have to worry about them. Now I've got 2 oxygens here plus 2 oxygens. So how many total oxygens do I have in my reactants? I've got 4. And I've got a total of 3 oxygens on the right in my products. So this is going to happen sometimes where you have some elements that are balanced already, but you've got to make sure everything is balanced. So how do we do that? Well, easy way to think about it is, okay, what's the common multiple between those? So the 3 is going to dictate things, all right, because it's only the one spot, where you've got 2 different spots here on the left. So what's the common multiple between 3 and 4? It's going to be 12. So if I want 12 total oxygens on the right, what number do I have to put up there as a coefficient? 3 times what equals 12? If you said 4, then you were right. Okay. Now, by putting this 4 right here, did this only affect oxygen, do you think? No, it also affects sulfur. So sulfur may have been balanced. So when you balance something to begin with, all right, you get it set, by changing something else, you may have to go back and rebalance it. So we now have 4 sulfurs on the product side, okay, which now we can see we're in worse shape than we were before. So let's go back and take care of sulfur, leaving oxygen until the very end. Why do I say oxygen to the end? Because you have 1 oxygen here, and you've got 1 oxygen there. It's in 2 different spots, where sulfur is only in 1 spot. A lot of times, if you leave the thing that's split up to last, it's much easier to balance it. So that's what we're going to do here. So I need to get sulfur to 4. That means I'm going to put a 4 right here as my coefficient. All right, so okay, that distributes into this sulfur, but it also distributes into the oxygen. So now, how many total oxygens do I have on the left? Well, I've got 4 times 2, so I've got 8 here, plus I've got this guy over here. So I've got a total of 10 oxygens. Is that balanced? No. So you can see it's a process. It's a puzzle, guys. You've got to try to figure it out. The more you balance, the easier it's going to get. So to get these balanced out, notice, do I want to change this oxygen at all? If I change this guy, I'm also going to change my sulfur. So I really don't want to do that, okay? I want to change just the oxygen that's by itself. So let's think. I've got 4 times 2 right here on the left. That gives me a total of 8. Well, I need to get to 12. So how many more does this guy have to balance out to the total 12? 8 plus what equals 12? 8 plus 4. So how am I going to get this guy, this O2, to be 4? I'm going to put a 2 right there. Okay, because then if I distribute it in, 2 times 2 is 4. Look, 8 plus 4 gives me a total of 12. So this is what my coefficients would look like. Okay. Now, ask yourself, do I need to have really that many? Do I need to have that many? No, I don't. Okay, so take a look. 4, 2, and 4. If you look back here at our last step, it says check. If coefficients are not in lowest possible, reduce down. Well, we can reduce these all down by 2's, but that's okay that we kind of saw that 12 first. Okay, because again, take your eraser. We can reduce this down. This is going to be 2. This one's going to be the 1. And then this one's going to be 2 as well. So if we were to just add this up, let's think. I've got 2 sulfurs, 2 sulfurs. I'm good there. I've got 2 times 2 is 4, plus 2 is 6. And then I've got 2 times 3 is 6. Now, if you notice that right away, great. If not, that's just another strategy, guys, that you can use. Find a common multiple to kind of help you with it. So there's a couple. If you guys want to pause the video and try the next one on your own, great. If not, I'm going to work it here in just a second. All right, so let's take a look. I'm going to move a little bit quicker here. We've got iron. We've got oxygen. We've got hydrogen. We've got iron. I'm going to put oxygen right here just to keep it, safe, or not safe. Keep it on the same level. Don't worry about it. If you want to put hydrogen first because that's what you see first, that's up to you. And this would be iron. I've got 2 irons on the left. I've got 1 on the right. I've got 3 oxygens on the left. I've got 1 on the right. I've got 2 hydrogens on the left, and I've got 2 hydrogens on the right. So the first thing I'm going to do is I'm going to kind of just balance my metals. Okay, remember, we can always go back and erase and change things up. So I need to put a 2 there. Bam, those are balanced. Now, I've got oxygen and hydrogen. Do you think it matters which one I start with? No. Notice hydrogen's already balanced, so we're all good there. Oxygen's the one we got to work on. We need to get 3 to balance them out. So to do that, I've got to put a 3 up here in my equation. Because again, this distributes out to both hydrogen and oxygen. So 3 times 1 for oxygen is going to be 3. Notice it changed my hydrogens. 3 times 2 is 6. So now I need to get this guy to 6, which means I'm going to put a 3 right there. Okay, so my coefficients would be 1, 3, 2, 3. My hope is it's getting easier. If I'm going too fast, again, pause and go back and redo it. Ask questions as well. Now, number 4. This is one, if you tried it on your own, great, but there's something new here. Notice we have something in parentheses. We have a polyatomic. So again, I'm going to start by saying, okay, I've got silver, but hopefully by now, guys, you recognize NO3. That's nitrate. That's one of your polyatomics if you look on table E. So I put parentheses around it. Even if you don't see parentheses around a polyatomic, if they don't write it, give it to you that way, I encourage you guys to put parentheses around it to make your life easier. So I've got NO3 right here. I've got calcium, and I've got chlorine. I'm going to keep it the same way. I've got silver. I've got NO3. I've got calcium, and I've got chlorine. Okay, I've got 1 silver on the left. I've got 1 silver on the right. Notice, by putting the parentheses, this is why I encourage you guys to put parentheses around your polyatomics. If I just look at this polyatomic right here, it might look like, oh, there's 3 nitrates. Guys, there's not. There's 3 atoms of oxygen in 1 nitrate ion. That's the difference. This is why you should get in the habit of putting parentheses around them all the time. Okay, 1 nitrate on the left. I've got 2 nitrates on the right. 1 calcium, 2 chlorines, and 1 chlorine. Lots of stuff to balance here. So this is the one that, you really want to follow that process. So I'm going to start with my metals. Silver, balanced, good. Calcium, balanced, great. So that's kind of the first one. Now I'm going to look at my polyatomic ions because they're the same on the left and they're the same on the right. I see them in both spots. So I'm going to balance them as a package deal. You can split them up into their individual elements, but I highly encourage you to just make your life easier and do 1 instead of 2. I have 1 total nitrate on the left. I've got 2 on the right. Well, I need to get that to be a 2. How am I going to do that? Put a 2 coefficient. That's going to distribute not only into silver, but it's going to distribute here to my nitrate. Well, notice I again changed silver, so I got to go back. Now I got to do some more work. So nitrates are balanced, calcium's still good, but silver has been changed. Go back when you change something and rebalance it. So I need to put a 2 over here. What else did that affect, though? Not only did it affect silver, but it affected chlorine. So now I have 2. Oh, look. Chlorines are balanced in the end. So if you follow that process, that little helpful guide that I gave you, that's what I have found to kind of, especially when you get to these double replacement reactions that you guys are going to learn more about in the next video, it makes it easier to balance by going through that because it'll just take care of it in the end. Okay? So if I'm going too fast, pause the video, slow down, go back and redo it. Last one we're going to do here, and then you guys are going to do the U-Try problems, and I will check them for you in person. So this one's a word problem. We've got to write the equations out first. Notice it says liquid water. So I'm going to write H2O. You guys should know by now what water's formula is. Notice it says liquid. So I need to put the state of matter with it or else you'll lose points. Breaks down. That means we have an arrow. Okay, so the reaction is taking place into hydrogen gas plus oxygen gas. There's my equation. So now I can go through and do my whole process. I've got hydrogen on the left. I've got oxygen on the left. I've got hydrogen on the right. I've got oxygen on the right. Notice each time, now I'm not putting their subscripts with them. I'm just kind of writing the elements out. Then I go through and count up how many atoms do I have of each. So I've got 2 hydrogens on the left. I've got 1 oxygen on the left. I've got 2 hydrogens on the right. I've got 2 oxygens on the right. So no metals, no polyatomics. We've just got hydrogen and oxygen. Notice, guys, that hydrogen is already balanced out, so we don't have to do anything with them right now. We may have to go back and do it. Balance out the oxygens. Well, I need 2 here. So I need to put a 2 right there. Well, what else did that affect? That affected my hydrogens. So now I have a total of 4 hydrogens on the left. So I need to make sure I get 4 hydrogens on the right. And I put a 2 there. There you go. So it's going to take practice. You're going to come into ones, guys, that are challenging. Okay, very, very challenging, especially, well, you'll see as you go along. But go on, you try these ones. When you get done, have me check them in person. Go back and rewatch these examples if you have questions. It takes practice. It may click for you in 3 or 4. It may take you 15. Don't give up, okay? Don't give up. Until next time, have a great day.